Hey students, it's me, Mr. Fitz. So I just want to take you through the city design project. And so what it's all about is basically just creating your own city map. And you'll notice like this is just from Google Maps. And here's, NYC iSchool. And these city streets are just created by sets of parallel lines, right? There's like parallel lines here, some parallel lines here, parallel lines here. And then those streets create city blocks. And the city blocks form all kinds of different shapes. So for example, there's something that looks like a rectangle, something that looks like a right triangle, and then a couple of trapezoids over here. But I'm not sure what they are. So if I could take this city map and put it on the coordinate plane and assign some coordinates to it, then I can actually prove what these shapes are. So that's what our mission's going to be, is we're going to create a city. It could be fictitious, or you could just create some neighborhood that, near you. If you want to look at Google Maps and like try and recreate that, you could do that. Totally fine. So let's look at the project. So for this activity, you'll be designing a city map or some other map that showcases your knowledge about shapes on the coordinate plane. You may use either graph paper or Desmos graphing calculator to create shapes on the coordinate, create your map. Your map must have a name, be creative, New York City is already taken, and all streets should have names. The intersections of your streets must form at least 5 shapes. Your map must include a minimum of 1 trapezoid, 3 parallelograms, 1 must have acute angles, and 1 right triangle. On the coordinate plane provided, we will provide you graph paper, or we'll talk about the Desmos graphing calculator as well. Construct an accurate 2-dimensional pictorial representation of your city. Here are the characteristics your city must meet, and we're going to talk about those in a minute. So, for example, I could just start, if I'm just working with graph paper, and please use a pencil and a straight edge. I just drew in these lines here, or line segments, with my pencil, and I did start with some vertical lines, created some parallel vertical lines, parallel horizontal lines, and then I can erase these little intersections here. That's why you should use a pencil. And it makes it look like city streets. Then I could create some diagonal lines. Look, I've already got one shape right here. It looks like a rectangle. So let's pick just a slope. I'm going to pick a slope of, say, -3/2. And then just going to plot some points. So I start with this one. So if it's -3/2, I'm going to go down 3. It's my change in y is -3. 1, 2, 3. My change in x is +2. 1, 2. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. So there's my street. I just go ahead and connect those points. Well, it's actually half of my street, right? I'm going to draw another parallel line right here, or right here, and I made a street here. And then I made another street also with that same slope of -3/2. So look at all these shapes I've created. I drew in another set of horizontal lines down here, and now I have tons of different shapes. I could even create, some street with a positive slope. Let's pick a slope of 1/2. So a slope of 1/2, what is that? My change in y is 1, +1. My change in x is +2. +1, +2, +1, +2. Go ahead and draw that in. Draw another one like that. Extend those, finish it off, and then I'm done. So let's go through those parameters for the project and make sure I meet all of those. So let's bring those in. So I'm going to go ahead and resketch this so you can see it all at once. So again, please use a pencil and a straight edge, and then I can erase all of those intersections, make it look nice and neat. Here we go. So I can drive around my city. Ooh. And then, what are the parameters? So it has to have 1 trapezoid. Alright, there's a trapezoid right there. It has to have 3 parallelograms, 1 with acute angles. 1, 2, 3. Here's the one with acute angles, right? They're smaller than 90 degrees. Oh, they're so acute. Little tiny acute angles. Alright, and then this has obtuse angles, right? And this looks like a parallelogram. And, 1 right triangle. I erased my right triangle. It was right here. So it kind of looked like that. Oh, but there's one over here too. Yeah, so I have 2 right triangles. Alright, so I have plenty of shapes. Now, what I need is a bank and a post office that are streets with positive slope. So here's a street with a positive slope, right? This was a slope of 1/2. And there's my bank and post office. Then I need a city hall and a general store on a negative slope street. Well, this was a street with -3/2 slope. There's my general store and my city hall. Then I need a hospital that's the midpoint in between a pharmacy and a hotel. Okay. There's my hospital. It's halfway between the pharmacy and the hotel. Oh, and then I need a park with boundaries that form a trapezoid. So there's my park. I could have picked this as my park. Doesn't matter. Oh, and then I need 4 stoplights at perpendicular intersections. So there are my 4 stoplights. Okay, so that's pretty much it. You also need to write a coordinate proof, and I'm going to talk about that in 1 second, and you must compute the perimeter of your park. So I'm going to give you some little tips here. So for the park, I like to pick a right trapezoid, a trapezoid with right angles on one side, because then I know I have horizontal and vertical lines, and those are so much easier to calculate the distance, right? So if I want the perimeter, I need all 4 sides. So I only have to use like law of right triangles or distance formula once, right? I could use a squared plus b squared equals c squared. Just go ahead and kind of sketch in that right triangle and figure that out. That makes it a little easier. And then for the proof, what I would say is I would pick a trapezoid or a parallelogram. I wouldn't pick a rectangle just because rectangles are a little more difficult unless you want to level up. Square, again, is the most challenging of the proofs that you'd have to pick, but it's your choice, right? So I would pick probably a trapezoid or a parallelogram and prove that's on the coordinate plane, so you can watch my coordinate proof video about that. So let's take a look at how I would do this in Desmos Graphing Calculator, because some of you who are really adept with Desmos Graphing Calculator and don't like graphing things on the coordinate plane might find that a little more enjoyable. So let's take a look. So here's my Desmos Graphing Calculator right here, and let's go ahead. See, you can see I just started with some parallel streets, horizontal streets and vertical streets like I did on the graph paper, and already I have some rectangles right here, right? So, and then let's go ahead and take a look at some other streets I could create. So I could create some negative slope streets. Right? This is a slope of negative 2x. So here are my horizontal streets. Y equals negative 20. That would be this one right here. Y equals negative 19. That's that one. Remember, horizontal lines are y equals something. And then I could create, you know, positive slope streets. Like y equals 1/2 x minus 5. Y equals 1/2 x minus 6. And here we go. And then just kind of move our way through the coordinate plane. And here I've got a bunch of shapes right now. I have a right triangle here. I have trapezoids. I have rectangles. I don't have any parallelograms yet, not that aren't that have acute angles. So let's go ahead and draw in some more. Oh, okay. Now I have a parallelogram here and here with acute angles. So again, you can just play around with it. And then if you wanted to shade in your city blocks, you can use the polygon function. You just type in polygon and then the coordinates of the shape separated by commas. So for example here's this polygon here and that has the coordinates of the shape. I could even put in this polygon. Here's my right triangle. Here's this one, trapezoid. Remember when you're plugging in the polygon, so it's just polygon open parentheses, plug in the coordinates in order around the shape. So if I start with like 0, negative 11, this one, and then I went across to 1.5, and you can just click on the points here, and it'll show you what the points are. So like here, it's 1.5, negative 11, 3, negative 14. I could click on this one, and it tells me, oh, that's 0, negative 14. So you don't even have to guess. You can just like click on the lines, and it tells you like what the coordinates are. So that's really, really useful. It tells you the coordinates of all the intersections. So you can go ahead and graph your polygons. Here's another one. Here's a parallelogram. There I have my 3 parallelograms, one with acute angles, one trapezoid, and one right triangle. And then, oh, yeah, and you can create labels. So you can, here's my bank, here's my post office, here's my city hall, general store, pharmacy, hotel, hospital. So I have everything there. Oh, I can even create my park. There's my park. All my stoplights. And so I have everything now, right? So this is a really nice way to kind of create this, and then you could share it. You can save it as a PDF and share it with us. You can post it in Classroom and just use this. And then you can use this to create your coordinate proof as well. Again, hope this helps. Please let me know if you have any questions, and thank you so much for watching. Oh, here's a little Owl City. Hopefully I don't get copyrighted for this, but I probably will.